Welcome friends. In the previous video we have seen the first second differences, and we have seen the various operators, the operator delta, the operator displacement, the operator Nepla, where we have calculated the differences when the values of the independent variable are at equal distances. And means any two difference of any two consecutive values is h. Now is there any procedure to find the differences when the values of the independent variables are unequals? Then x1, x2, x3 dash dash dash, these are the values, and the corresponding values of the function f of x, f of x0 comma f of x1, f of x2 dash dash dash, these are the values of the function. So these are the arguments, and these are the entries. Now here we assume that the x0 minus x1, x1 minus x0, or x2 minus x1, like this, x3 minus x2, these are not necessarily equal, not necessarily equal. It may be equal, it may not be, some may be equal and some may be unequal, necessarily equal, or they are unequal. Then we define the first divided differences. We call this as the first divided differences, first divided differences, and we use the symbol delta dash, first divided difference, and this is x0 between the point x0 and x1, and we denote this as f of x0 comma x1, and we calculate this as f of x0 minus f of x1 divided by x0 minus x1. The first divided difference delta dash for the points x1 and x2 equal to f of x1 comma x2 equal to f of x1 minus f of x2 divided by x1 minus x2. The first divided difference between the points x2 and x3, this is equal to f of x2 comma x3 equal to f of x2 minus f of x3 divided by x2 minus x3. So in this manner we calculate the first divided differences. The second divided differences are denoted by delta dash square, and it is between the point x0. Second divided difference are between the point x0, x1, and here the point x2, x1 and x2. Okay, so simply we denote it by f of x0 comma x1 and x2, and we calculate it like this: f of x0 comma x1 minus f of x1 comma x2 divided by x0 minus x2. The second divided difference between the point x1, x2 and x3 equal to x1, x2, x3 f of x1 comma x2 minus f of x2 comma x3 divided by x1 minus x3. So likewise we can write the nth divided differences, and the third divided differences delta dash cube of f of x3, and for the point x0 we denote this as a x0, okay, and x1, x2 and x3 equal to, we need 4 points for the third divided differences, x0, x1, x2 and x3. So second divided differences x0, x1, x2 minus f of x1, x2 and x3, and divided by x0 minus x3. So in this manner we can define third divided differences. Similarly, the nth divided differences at x0 and other points x1 to xn and equal to, this is f of x0 x1 up to xn. Total these are the n plus 1 points. So f of x0 to xn minus 1 minus f of x1 to xn divided by x0 minus xn. So first divided differences between 2 points x1 and x2 equal to f of x1 minus f of x2 divided by x between the point x0 and x1. x0 and x1, that 2 points, so f of x0 minus f of x1 divided by x0 minus x1, whatever that points we have taken. If we choose x1 and x2, then f of x1 minus f of x2 divided by x1 minus x2. Similarly, for second divided differences, we need 3 points x0, x1 and x2, and the differences of the first divided differences. Okay, so in this manner we can find the divided differences. And if we write the divided differences in the tabular forms, so let us write the tabular form of the divided differences. These are the arguments. First we write arguments x0, x1, x2, x3. Okay, and entries. So entry is f of x0, f of x1, f of x2, f of x3, and the first divided differences delta f of x between the point x0 and x1, between the point x1 and x2, between the point x2 and x3, right? Second divided differences, this is between the point x0, x1 and x2. This is the difference between x1, x2 and x3. And four divided differences, third divided differences of f of x, these are the x0, x1, x2 and x3. So in this manner we can construct a difference table for the divided differences. Thank you friend, thank you for